Hello. Just checking if everything. Okay, everything works well. So today I'll do some hacking on Oxlint, which is a budding Rust-based linter for JavaScript. It's part of Oxy or OXC. It's a project containing a lot of tooling that is built with Rust for JavaScript. So the project has a parser, linter, formatter, transformer, minifier, resolver, roll down, and a JavaScript engine as well. And I've been hacking on it for quite some days without success. So I'm going to try to do this on a stream. I don't hope success again, but just the motivation to contribute. So a few days back, um, I took on an issue for Oxlint to add no useless assignment rule. Um, just to quickly summarize what this rule, I mean, the name is quite clear, but it essentially is a linter rule to catch useless assignments. Useless assignments are also called as dead stores. So any assignment that is made that is not used before being overwritten is a useless assignment. So this is useless here. There are a bunch of examples. And the rule should capture such instances. I mean, on the first look, it seems a bit easy, but it is not. Like, trust me, it is not. I've been trying this for quite some time. The examples here are quite straightforward, and they might be solvable by some simple tracking of references. But one thing that immediately comes to your, like when you are trying to solve this, is that you need to solve this considering that there will be things like scopes. Like a variable reference can go through different scopes, and the definition of used changes when there are multiple scopes in play. So when I started on this, I used a simple I'm not sure how much the volume of the music is, but I used a simple rule where I would just count. I would just check if I would iterate over the references of a variable and then check if there is a read before a write. If there is a read, then the variable is used. If there is a write immediately after like the first write, then the first write is useless. And this solves the easier parts, but as soon as you introduce a scope change, this breaks because at static analysis has to kind of consider all the cases. So at runtime, the code might go into one of these cases, one of these situations. For example, let's take this code where there's an if condition with a return statement. So at runtime, the code would either take this path or take let v equals to used and then do something, because the condition may be true or false. Depending on that, the program can take two paths. But at static time, or like at when we're doing static analysis, I would have to consider both these cases because at runtime anything could happen. So if I have to say that a certain assignment is useless, I need to prove that it's useless across all the paths. So in this case, this v equals to used, this the same logic that I applied it here, that if a write immediately comes after a previous write, then it's useless. It does not work here because this is one of the paths, and even if it is being overridden here, the value of v is being used here for this function call. So this is not useless, rather this is useless because you are assigning a value, but then this value is not used anywhere in this block, and the flow returns from here. So essentially it's a user assignment. Now there are also other cases where this should not fail. So for example, let's take this case where v is defined here, and then it is also overwritten here. It's actually very similar to the previous example. So this is another assignment to the variable, but it's actually used here before being returned. And in the other path, if the condition is false, the value to v is used. So this assignment is also used, and this is used as well. So there is no unused assignment. Things become tricky when there's a for loop because the same code gets executed again. So there is a chance at build time, you can never know when the loop will exit. So you would have to assume that the control may flow back to this block or this piece of statements after the end of this thing. So you have to consider these cases. Essentially, what it boils down to is this thing called control flow graphs in compilers. Essentially, it is a graph built of nodes called as basic blocks. So basic blocks are a collection of statements in a program. So for example, in this case, there are a few basic blocks here depending on how the control flows. So whenever there is a statement that changes the direction of the control, we change the basic block. So in this case, let v equals to used is one statement, but after this statement, the control may either flow to this block or may go to this block depending on the value of the condition variable. So in this case, this would be one block, this would be another block, and this would be like a third block. So the control is here. The condition is also part of the first block. Now, in case condition is true, there is a directed edge to this block. In case it is false, then there's a directed edge to this block. And in case of a return, there's a directed edge to like a end node. So control flow graphs are definitely going to be useful here, and this is what I also tried doing. But there are a lot of edge cases that I have to handle here in this case. That's why I said like these examples are quite easy. But if you go to the source code for ESLint, there is a whole bunch of tests for this rule that I can show you. Let's see, let's go to tests, lib rules, and yeah, so there are a bunch of tests. So like these are basic ones, but then you also get things like export statements. So in case of exports, the assignment is inherently used because it is being exported from the module. So I'll have to handle this in a special way. Then there are some like these are, this I'm going to ignore because this is like ESLint specific config. But things like unreachable code. So unreachable code should never be marked as useless because it's unreachable, and it will be highlighted by like a different rule. Then there's particularly tricky cases are try catch, because control flows in a very different way in a try catch block. Um, and I'll show you like how Oxlint handles this. So I have OpenPR that uses control flow graphs, but I'm also trying a different approach because I hit a dead end there, so I started implementing this from scratch. So Oxlint has like a very good tooling where you could just create new rule, and it creates a boilerplate, and it adds like tests and whatnot, and yeah, like you get a template where you implement, and every rule is implemented in a visitor pattern. So if you know the visitor pattern, it's essentially a way to access or traverse nodes of a graph or a tree uh, in a way that you can control. Sorry, you cannot control the the traversal, but there's a visitor that controls the logic, versus like something called as walking, which is where you traverse the nodes yourself. So in this case, like there's a trait in Rust called rule, and it exposes like a bunch of methods here, like run once, run, and run is a method that runs on each node type, and then you can like filter out the node type that you want to run your logic on, and then do stuff there. Here I'm using run once because what I want to do is I want to take all the variable declarations in the program and then run this logic for each one of them. I mean, I could have also done it for using run and specifically for node type variable declaration. It's almost the same. And I haven't yet compared like how the performance differs, but yeah, I'm going to try with run. And right now, what my program does is it it filters out the variable declarators, and um essentially, yeah, it checks if it has an initialization. If it is initialized, then initialization is also a write, like is kind of a write. And what Oxlint provides, it provides a set of APIs to access via this context object of type lint context, and it has a lot of useful APIs to access the abstract syntax tree that was created before running these rules, right? Because the linter did some processing. It read the source code. It constructed a syntax tree. It did some passes over that syntax tree and then enriched it with information. So finally, you have this context API, which kind of lets you access different parts of the syntax tree and do like different things on top of it to get like to be able to implement certain logic that your rule wants to check. And one of these APIs is under scoping called resolved references. So get resolved references gives you a iterator over the references of the symbol, and references are everything that kind of use the variable. So, and the references could either be write, they could be read. Write references are essentially where you do an assignment to the variable, and read are where you read the variable kind of to access the value that it has. So the logic that I'm applying is that I get for each variable declared in the program, I get all the references to the variable, and then use this, I analyze whether these writes and reads are in proper order. If there is if there are two consecutive writes, then the first write is useless. So essentially, it's going back to the same logic, but I'll show what is different here. So one thing I'm checking is that um, for all writes, I'm checking if there is a read between. I mean, this is something that I did recently. I was previously doing like something different, but I'm just playing around. Let's see how it pans out. But right now, what I'm doing is I'm checking if there's a read between two writes. So this function has a reference, right, which is being checked, and then for all other writes, it iterates over. It excludes itself from the logic, and if there is a read between these two writes, it means that the first write is used and it's not useless. So it checks it for every other write in the program for the same variable. Um, and there are two cases here. So if the second write is in the same control flow graph block, or is in the same basic block as the second write, then uh, sorry, yeah, if the read is in the same block as the write in question, then I just have to check if the read is coming after the write. And one of the ways to do it is using something called a span. So a span is it's literally a span of code represented in a data structure, and it holds start and end positions to the exact piece of code in the source code. So if I check that the reference span start is greater than the first, like the write in question's end, then I can say that it's after the write. This is also a bit tricky in cases where you do update assignments, where you do like a equals to a plus 1. So in this case, the read is being used first, but semantically or in syntax, the read comes after the write. So there's this edge case, but I'll handle it later. So if they're in the same CFG, then then return true, because then the read comes after the write and the write is used. Um, Actually, I don't have to return anything. I'm not sure why the compiler is not complaining here. Expected Boolean. Okay. This is just a filter condition. Okay. So I'm basically filtering out if there is a read between. Yeah. Okay. And the other case is uh, where the basic block IDs are different. So essentially the write is in a different control flow graph and the read is in a different block. What I want to check is that the two blocks are connected. And the way to do this is there's this function called isReachable, which checks if one node is reachable from the other node in the control flow graph. And if it is reachable, it means that the control can flow in this path, and the read can be accessed in the path of this write. So yeah, this is another way when the read and write is in different block. And finally, if there is a read between, then I just return. So if I find a single, like even if there's one read between two writes, or let's say there is a read that is being okay, I think I see the flaw in my logic here already. Um, Here I'm writing for all writes, but what if it only has reads? Um, Okay, if it does not have rights, okay, then if rights is empty and reads is not empty, um, then just return. Okay, so what it will do is, yeah, I mean, it will capture these cases where the writes is empty and the reads is not empty. It means that there is some read to the variable. Um, okay, now I think I need to do this. If the writes is empty and the reads is also empty, then it means, yeah, okay. So I think I need one more check here where I do for r in reads. So if there was no read found in between, I would just check if there is any read that is reachable. So check. Yeah, so basically I will just use the same logic here where I take the CFG if it is in the same block, and it is this return, this, then return. Okay, so first we check if for all the writes there is no read. Okay, there is none. Just want to remove this. And then if there is no read between two writes, I just want to check if there is any read that is reachable. Yeah, whatsoever. And let's test this. I mean, previously I tested like all the past cases were failing, and all the failed cases were passing, like except two. So yeah, it was too aggressive. I think this might improve the situation a bit. Uh, yeah, the building does take like some time. Okay, so now I'm a bit being too lenient, where 20 cases that were expected to fail passed. But yeah, okay. Now we are half an hour between both the cases. So let's take an example of this one. Why is this not being marked as failed? So we have the unused assignment if the condition is there, and equals to used. Okay, what could be happening? So it takes all the rights. Okay, and so this rule basically penalizes such cases where um, what I could do is I could check for each read, is there a right in between? If there is, continue. If all the reads have a right in between, then yeah, it just failed. If there is okay, so essentially what I want to do is if there's a rise in between, which means that yeah, if it's in the same block, then start span is greater than. Okay, so if there is a right in between, I don't want to return. I just want to do continue, else return. Yeah. So now finally, I've checked on both the sides. Like if there is no read between writes for each of the cases, it is overwritten all the um, cases. And then in other cases, if there is if there is even one write between, or if there is even one case where there is no write between a write and read, then just return. Okay. Yeah. Is write between. Okay. I need to use references. Yeah. So it will not borrow the value. Few Rust quirks. Okay. Finally, you'd only complain when there is no this thing. Okay. Cool. Let's try. It has been snowing in Berlin for a couple of days. How is weather at your place? Wish you all a happy new year, by the way. Okay, so we have 27 cases expected to fail. Now they pass. So it's a regression, but did not improve the situation. Okay, now this also starts failing. Okay. So it is failing for this case. V equals to unused. Okay. This is the most basic case. Why is it failing here? So in this case, it would have just skipped this block because there are no writes. Then it would come here, then there are reads. Is there a write between? Anyway, if this wasn't here, so for this case, you would have writes if there is, if it is in the same block, yes. If the ref span, if the write span is no, there is no write in between. Wait, but I think I think I'm missing on a big thing here. So when I'm checking if there's a read in between, I must first check if this write is even reachable from. I mean, okay, in this case, it's fine if there's no read. This is a like optimistic case, but in this scenario, I need to check if this read Okay. If read is not reachable, then just continue because we don't care about this read. Let's check. Okay. So now we are down to 6 failing tests and 27 tests that should have passed. Okay. Cool. I think missing on a few things. I'll take a break and we're back in a few minutes. Hello, hello. I'm back. Okay, I think I saw a message. I'm sorry I could not reply. Okay, let's go back. Hey, Kiran. I think you asked something about starting with Rust. I would say like the best way is to start building small projects, maybe like some CLI tools or yeah, maybe just solving some small problems using Rust. Maybe write a small text parser or um, yeah, like a tool that reads some input, process it, and generate some output. Yeah, like build some small things, and I think that's how you could pick up Rust. Uh, for Rust specifically, I mean, I'm also not that well versed with Rust. I also use Go quite frequently, but I think what I've found out, like especially with the features that Rust provides, um, it has a very good pattern matching syntax and stuff like compilers or interpreters or linters where you have to work a lot with syntax trees. So anything that has to do a lot with trees or graphs, I think I've seen writing Rust code is much more expressive because then you can pattern match on the type of nodes. So I think you could try with playing with like a bit of interpreters if that is something that interests you. Or I think what I've seen what people do is yeah, just take a tool that exists already and then implement it in Rust. I mean, that's the easiest way to start. Okay. So the last time I tried to check, we had 6 failing tests for the failed scenarios and 27 tests that passed. Sorry, that failed but were expected to pass. I mean, let's see. Now it comes down to debugging. And first of all, I'll try to fix all the failing tests and then go to the passing one. So why is this test not failing? So then this is unused. So this is an initialization and Okay. So it will pass this. And it will kind of run through this. It will come here for our in reads. Should be reachable. Right in between. Yes, there should be a right in between. Then continue. So ideally this test case should be marked as failed because it should reach here. Checking why it does not. So writes would be v equals to used. Reads would be this thing. So for our in writes, you have this. CFG ID span is equal, no it is not. Then is a read in between. There is no read in between. So reads, this is not in between this, so I should say false. I mean there should be no read. So yeah, then I should come to here. If our reads our CFG ID is a different one and is read reachable. If it's a different CFG block, so it should take CFG dot is reachable from right CFG block ID to this, and it is reachable. So if it is not reachable, then continue, which is not true. So it will come here. Is right between. Is there a right between ref span, this thing, span, Holland? No, it is not. Right CFG block ID is not the same. Is not the same. CTX is reachable. Yes, and this is okay. I mean, only for this case, this right should make sense because here we don't know if it is reachable, then it says true. So if there is a right in between, then yeah. So I don't want to use the reachable API because actually I'm not sure if it is the same block would reachable return true. Okay, so it returns true. Okay, cool. So this should not matter. So is right between should be true and should continue to the next read, which is there's no next read, so it should just fall through here. Okay, let me narrow it down and I want to only use this case. This is classic print debugging. And for the pass array, I just want to okay, I'll just use an empty array for now and then just test. I want to check print ln. Okay. Now that I have only the case, let's see what it prints. So it should come here and then okay. So it runs twice, but once for this and once for this, which is expected. So this case, this is where it is returning true. So there is this API that lets us print the source text. It should be easier to debug. Let's see. Because we unused, checking rights for span V, which would be this used. Okay, this is weird. I mean, this is fine, but it doesn't even reach here. Okay. yeah, so this is a problem here because in this case it's reachable. This would right CFG is reachable. Yes. If this from this, okay. Yeah, so this should be the check because this is not sufficient, right? Because let's say if these are in two, these could be one after the other, and okay, it still passes. So is read wait. So reads is read between, right? So that start should be greater than right span. That's true. So this will be anyways true. I want to check if ref span dot end is less than r span dot start, and similarly here. Yeah, because I want to check that it is reachable, but it's also before the read. Sorry, it's before the write. Yeah. Okay, cool. So this passes the case. So now it correctly highlights that this is not used. Let's try to run it against all other cases. Oh, for now. Okay. Okay, two less failing cases. Now let's try this one. Okay, this is it. I think I'll not run the past tests for some time, so I just comment it out. Now, in this case, what should have happened is for this assignment, there is a write immediately after. So it should not, it should just complain. So let's see what is happening. So v equals to unused. V is used. Checking writes for span v used. Checking writes for span.
चालू आहे.
नाही मी हे पॉज केलं.
ओके हां ते एकदा नीट लावलंय का बघ आणि सगळ्यात मी त्याच्यामध्ये डिटर्जंटवाला टॅबलेट टाकले
हां हां
आणि सगळ्यात हॉटवाल्या ह्याच्यावर लाव.
ओके. सायली ती खालचं तो कपडा लावून धुवायला खालचा कपडा लावून टाकू ना. हां हां त्याने काय होतं. ओके आणि ते कापड धुवायला टाकतो नंतर.
आधी त्याच्यातला स्लश काढून बघ. मी तुला वातांपासून सांगत होते कर कर कर, तू हो 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 बोलतोस आणि नंतर बोलतो मी काय मदत करू तुला. आणि नाही कर.
Hello, 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 hello. Okay. Cool. Let's try for this one. So chicken rice a V, and it should be this, then this, then this, no, then this, then this. Okay. It says there is a read between false. And this two, there's this two, and this two. Okay, so in this case, we fail because this is in the same block. What I can try doing is let mode. Don't have to break necessarily. Do I have to break? And then I check this, and then I do if is reboot and then return. So wait. I mean, if it reaches here, I'll have to rethink this logic a bit. So the problem now is that this is read between. Let's say if it finds read between any write, even on the same path, then it just fails because I could try to combine these two, but I can see that kind of affecting other cases where I could do something like is right between. So you do something like there's a right found, then you just skip. And there is a read, then you return. What would happen here? I mean, would this be even necessary then? I mean, this might be useful for random reads. I mean, there's a lot of code repetition. I'm not caring about the code quality right now. I want to check if things work. I can come back to like yeah, reducing this duplication by moving them to a function later on. Okay, I mean this test case passes, but I'm sure some other test case will fail now. Let's see. I just want to make this one pass and then let's try all other failure cases. Okay. So only two test cases that were expected to fail pass. Okay, this may be passing because I just skip var um, right up front here. So if it is of type var, then I just skip this because vars are a bit tricky. Maybe what I could do is if it is of type var, then I don't check the initialization, but I still check um, uh, the rewrites. So essentially assignments. So I do something like and okay. Still two failing cases. Um, okay. So this is this case where you have a update expression or like a self increment or self an assignment where the expression on the right side uses the read, but in terms of references, semi like syntactically, this reference would be after the write. So yeah, these are some tricky cases. So now let me try to organize this a bit better. Uh, this right between, this read between. So essentially it's basically a is reference between check. So what I could do is I would say is reference between. Yeah, code completion is amazing. It just helps me with this thing. So let me just confirm it used reference CFG ID and then start CFG is equal to reference CFG. This. Okay. Yeah. Cool. Now wherever I have the between checks, I could just replace this thing with cool. Let me check if all the other tests still work. Loop Looks good. Let's see. Okay. We still have the same failing tests. Now, how do we handle cases like x plus 1 or x plus plus, where this thing comes before this thing? So one way is to sort the references before passing. Okay, this is a good case for the default thing, right? Like if the span of A starts before span of B, then yeah. I hope I don't get any rust issues here. Okay, cool. Everything still works. So I need to sort by start, compare. So this is the default thing, but if it is an so let's say if this is a right, if um, exactly. So I'll do the work here. If A is right, same expression. Okay, need to take a break. Okay. If it is a right, and serious no, okay, dot no ready. Get paved. I think there's a parent node. Assignment dot right is always defined, right? So I don't have to do this. Parent dot kind is assignment expression. Is right. I think there's something called binding identifier. What is assignment expression? Right as an expression. So I want to check if assignment.write accesses a symbol. Member expression. So where is the impl for? I mean, to solve this case, this would be like a binary expression because it's binary, like a plus operation. But yeah. So it could either be a call expression, a binary expression, or like, yeah, whatever expression it is. So if we do match assignment dot write, and for now I would do something like should I say case name? What? So what is this? Enum expression is of type this, right? So it is an expression. Yeah. So binary. I want to check if a certain value is being used. Let me check if there is any other rule that uses this. I'm sorry, binary would be like a comparison operation. So I'm not looking for binary. I'm looking for Boolean entity. Yeah, I think it's binary. So I have a binary expression and I want to check if so let's span is equal to binary dot span. And then span has like certain methods that can be used. Contains inclusive and simply size contains yeah, so basically I need to check if this contains any read. So basically I would have to do something like references dot any. Oh no, I mean it'll complain here. So I need reads. If it is read and let r span is equal to, yeah, I don't want this. If span dot contains inclusive or span, yeah, so this is what, so if this binary expression contains any of the read references, then return. So essentially what I want to know is okay. Okay, I'm stuck in this. I'll try to fix. I'll try to see. But I think I will end the stream for now and I'll resume on this sometime later. That's it for the stream. I'll see you in another session where I hack on this rule in Oxland. Until then, take care. Happy New Year.